again. I gather that it might have been difficult to hear me before as the loop was playing, but I just wanted to welcome everybody. Ian will obviously go through the seminar, but it's great excitement. We have a lot of people signed up, and we see a lot of people already joining the meeting so far. There may be more to come, but we obviously want to start on time. So just to let you know that we will be recording Ian's presentation, and at the end of that I will stop the recording and we will carry on with the Q&A, which will not be recorded, just so that you know that your privacy policy is in place there. So with that, I'm going to hand over to Ian. The recording's already started, Ian, so whenever you're ready, we look forward to hearing about safe handling of bitumen in the supply chain. Thank you.
Okay, thank you, Siobhan. Thank you to everyone who's registered and signed up online. I'm going to turn my camera off during the webinar. That's just to make sure that we've got a good network connection. But rest assured that I am here. Just during the webinar, you'll notice that your microphones and cameras are muted. We will take questions at the end, at which point the cameras and microphones will be unmuted, so we can start that discussion. If there's anything urgent that you feel you don't want to be missed, just pop a question into the chat function and we will monitor that. But if you can, please try not to start a parallel discussion in the group chat, because that can be a little bit distracting for everybody. So for those who don't know, my name is Ian Lancaster. I'm the technical lead for Eurobitume, and today I'm going to be talking about safe handling of bitumen in the supply chain. One last little bit of housekeeping before we start. We've already explained that the webinar will be recorded. The Q&A won't be recorded, and this webinar, as with everything that we do within Eurobitume, is covered by our compliance guidelines and the Eurobitume data protection policy, all of which was attached to the webinar invitation. So let's talk about safe handling of bitumen in the supply chain. And there's a key message that I want to get across to you today, right from the very start, and it's of critical importance to the rest of the webinar, and it's a critical importance to you as people that are interested or using or handling bitumen. And I need to stress to you that bitumen is a safe product when handled and stored correctly. So long as we take all appropriate measures to handle bitumen and store it in an appropriate manner, then it is a safe product to use. Absolutely key, absolutely critical. So let's have a look at the bitumen supply chain. What does it really mean? Well, for the purposes of today, we're going to start not in the crude oil field, but we're going to start at the refinery or terminal where the bitumen is produced and stored. From that refinery or terminal, the bitumen will be loaded either into a truck, a ship, a train, maybe even into a container. And then it begins its journey to end users. On arrival at the end user, the bitumen, the customer, the bitumen will be unloaded into a storage tank, and it then enters the next stage of its life through production at the production site. So mixed with aggregates to form asphalt, mixed with fillers to form roofing and waterproofing membranes, those sorts of things. And then finally, that bituminous product, the asphalt, the roofing felt, is transported to the job site. And that's effectively what we're talking about in terms of the bitumen supply chain. Now, we're not going to cover all of that as we go through this presentation, because there are a lot of things that we would need to consider, and it would make the webinar be potentially a very long process. So we're going to focus primarily from loading at the refinery to unloading at the production site. So before we start, to underpin safe handling, we come across two phrases very regularly, and those are hazard and risk. And we need to understand the difference between hazard and risk. So a hazard is anything that has the potential to cause harm. And the risk is a measure of the hazard, the material that can cause us harm, and the level of exposure. So risk is a function of hazard and exposure. So if you look at the graphic there, we have a swimmer in the water. We also have a shark in the water, and the shark is the hazard. So what is the risk in the picture there? Well, as we see, the shark is very close to the swimmer. The likelihood of exposure of the swimmer to the shark is very high, so therefore the risk is very high. If, for example, the shark was, shall we say, 10 kilometers away, then the hazard is still there, but the risk of exposure is much less likely because the shark is a significant distance away. So the overall risk comes down. So it's important to understand the critical difference between hazard and risk. So just to reinforce, hazard is the potential for something to cause harm. Risk is the probability of that harm actually taking place as a function of exposure. So once we've understood the critical difference between hazard and risk, then we can begin to take some measures to reduce risk. And there's a well-established risk reduction hierarchy. As you see, as we develop, this is an inverted triangle. And the first, most effective thing that we can do in risk reduction is a step called elimination. And that means we will remove the hazard. Well, what does that mean in practical terms? Well, if you think of working at height, the hazard is working at height and falling to the ground. So you can eliminate that hazard by moving the work to ground level. Doesn't work with everything. There are times when elimination is not possible. Our next risk reduction strategy is called substitution. And that means we replace the hazard. And we can think of that in bitumen terms of replacing hot mix bitumen with an emulsion or a warm mix bitumen. So we substitute the hazard, we change the hazard there. The next step that we can undertake is what's known as engineering control. So here we aim to install a physical barrier between the hazard and the people that are likely to be exposed to it. And that can be things like extraction systems to take away emissions. So we start to isolate people from the hazard. The next, do apologize, is administrative control. Much less effective, but is still in our toolbox, if you like, for risk reduction. And what we mean by administrative control is really changing the way that people work. And a good example of that could be on an asphalt paving site, rotating the operators. So rotating the person who drives the paver with the person who drives the roller. So we change the way that people work, and that reduces their exposure to any hazard. And then the very, very last thing that we have in our toolbox is personal protective equipment. And again, it's another kind of physical barrier that aims to prevent the hazard causing any damage. So that's our risk reduction hierarchy. And I think it's very, very important to remember that the most effective thing we can ever do in terms of risk reduction is elimination. The least effective thing we can ever do is personal protective equipment. Now, that's not to say that personal protective equipment doesn't have a place. It does. It has a very, very important place within risk reduction strategies. But the most effective thing is elimination. Now, for us in the bitumen industry, we don't have the luxury of elimination. We don't. So we rely very strongly on the other controls that we have in place to manage the risks. So, what are the hazards associated with handling bitumen? Well, there are a number, and we're going to focus on 5 of them today. First of all, contact with water. That might seem to be an odd thing, but it is a fact that bitumen and water should not be allowed to mix, and the consequences of allowing bitumen and water to mix are really quite potentially dangerous. The next is perhaps more obvious to anyone who's in the bitumen, asphalt, or waterproofing industries, and that's elevated temperature. By its very nature, we need to transport bitumen at elevated temperatures. It's handled, generally speaking, at high temperatures. It's mixed with aggregates and fillers at high temperatures. So elevated temperature is a key hazard for bitumen. Next is bitumen emissions, and that can be related to elevated temperature. As we heat the bitumen up, we can get an increase in emissions. Perhaps less well known is hydrogen sulfide, a toxic chemical which can build up inside bitumen storage tanks. And then finally, we have high pressure. And so today we're going to look at these hazards and what we can do to reduce the risk that's associated with those hazards. And just to remind everyone, we're not going to look at the extremes of the supply chain. So we're not really going to look at inside refinery operations. We're not going to look at operations at the production site or operations at the job site, because it makes the whole hazard matrix very, very complicated and extensive. So for the purposes of today, we'll be looking at the hazards that can be and risks associated with loading and unloading. So what do we have? What are the hazards associated with loading bitumen? Well, there's a bit of duplication with the slide that you've seen before, and what we have are contact with water, elevated temperature, emissions, hydrogen sulfide, and then there are some site-specific things that can create hazards. And one of those is working at height. We may have a loading system which requires drivers to loading operatives to be at height to load trucks and that sort of thing. So let's start to look at those in a little bit more detail. Now, the first thing we're going to look at is contact with water. And I can't stress enough, really, that bitumen and water should never be allowed to mix. We must take steps to ensure that bitumen does not come into contact with water, because the consequences can be very serious indeed. And this starts right at the very, very beginning of the supply chain. If we think that a vehicle is going to come to a refinery or a depot and it's going to load bitumen, the very, very first thing we need to make sure is that the delivery tanker is clean, dry, and uncontaminated. And here we can't simply rely on paperwork. We can't rely on record keeping. We need to carry out means of inspection. We need to have definitive evidence that the tanker is clean, dry, and uncontaminated. Well, why? What are the implications? Well, if water is in a tanker and we load bitumen on top of that, hot bitumen at, for example, 160 degrees can cause the water inside the tanker to expand between 1600 and 2000 times. So 2 litres of water can potentially give us 4,000 litres of steam, and that steam has a volume. That volume creates a foam, and potentially it can lead to a spill, what we call a boil over. So we must ensure that the tanker is clean, free of water, uncontaminated. And the things we can do, primarily inspections. We can inspect the tanker, make sure that it's clean and dry. We can look at loading records. We can look at systems we have available to prevent water, and also we can look at maintenance. So I just want to touch on how water can enter into tankers, and into tankers. Man lids left open. If a man lid's left open and we have a lot of rain, and obviously we've seen a lot of heavy rain recently, a significant amount of water can enter into a tanker if the tanker is left open. Condensation. If a tanker is left cold and unused for a significant period of time, water vapor can enter. We can get a significant amount of condensation, and condensation leads to water buildup inside the tanker itself. What about the previous loads? Can we be absolutely certain that the tanker has not carried something like bitumen emulsion? And if there's emulsion there will be water present, and water then will start to boil once bitumen is loaded on top of it. So that's the hazard. And we can minimize that risk by doing things like inspections, looking at loading records, safe storage systems that prevent water ingress, and carrying out appropriate maintenance and recording that maintenance. Within Eurobitume, we have developed a loading compatibility matrix, which gives advice on which grades of bitumen can follow previous loads. But I want to draw your attention to the very top line of the compatibility matrix, which states that the tank must be free of water before loading with hot bitumen. It is the most important thing when loading a tanker. And the compatibility matrix can be downloaded from our website. I'm now going to show you an example of what happens when bitumen comes into contact with water by showing a little video clip. Before I actually show the clip, I'll give some background to this. This is a real incident that occurred some years ago. The tanker in question was receiving its very first load of the season, and the records indicated that the previous loads at the end of the last season were bitumen, and so loading was allowed to proceed. There were some early indications that the loading was not going as planned. There seemed to be a lot of steam and a lot of emissions coming from the tanker, but rather than stopping, loading was allowed to carry on. And this is what happened. You can see bitumen being ejected from the top of the tanker. You can see bitumen flowing out from the bottom of the tanker. You saw where the driver ran, and you can see bitumen coming over the sides there. An awful amount of damage done to the delivery vehicle, to the tanker, to the loading gantry itself. Very, very fortunate that the driver involved was also not injured. What was the cause of this? Well, the previous load at the end of the last load at the end of the previous season, before bitumen was loaded onto this tanker, was bitumen emulsion. And so what happened when the hot bitumen was loaded was a crust of bitumen that had formed over the top of the emulsion, melted, hot bitumen enters the emulsion underneath, that starts to boil, and bitumen comes over the top of the truck. So this is an example of what can happen if water is present inside a bitumen delivery vehicle. What can we do about the risk associated with temperature? Well, we can observe our maximum safe handling temperatures. That's a very, very important thing we can do. So we ensure that bitumen's used for paving applications isn't handled above 200 degrees, and for industrial applications it's not handled above 230 degrees. So if the first thing we can do is observe our safe handling temperatures, and that's very important. But then what else can we do? Well, we can manage the risk by managing exposure. So we can keep our temperatures as low as possible. Make sure that we observe the recommendations from the loading compatibility matrix. We can automate loading so that we don't place personnel at risk of bitumen at, for example, 180 to 220 degrees. We don't bring them in contact with it. We can use personal protective equipment. Remember that personal protective equipment was at the bottom of the risk mitigation strategy, but it is a very important way of reducing risk. And also we can exclude other people from the loading operation. So we can reduce our temperatures, we can try and automate loading so that personnel are not there, we can use PPE, and we can exclude other personnel from the loading operation. And if we take all of those steps, then we make a significant move towards reducing the risk associated with loading bitumen. So let's look at how we manage that risk by using appropriate personal protective equipment, or PPE. Well, there's a very simple thing to remember when it comes to handling bitumen, and we can minimize the risk by making sure that we don't have any exposed skin. So we need to wear a safety helmet, preferably fitted with a chin strap. That means it keeps the safety helmet on if we're exposed to high winds. A full visor to the face. Protect the face from any splashes of bitumen. Safety glasses and a neck apron. Safety glasses offer a second level of protection behind the visor. So if the visor fails, we still have protection for the eyes. A neck apron, preventing any drips to come round the back of the helmet. Heat-resistant gloves with long sleeves. Cotton fire-retardant high-visibility coverall. Protects all of the skin. Worn over the boots. And finally, safety boots that can be easily removed in the event of penetration of bitumen beneath the coverall. We need to make sure that we can get those off easily. Always remember that personal protective equipment is there to protect you, and it's important that we wear personal protective equipment at all times. To not be tempted to remove personal protective equipment if we're delivering on a particularly hot day, and also to remember that we have to maintain our personal protective equipment. The helmet and the visor that you can see on the left of the screen is covered with bitumen. That needs to be replaced. It's not a good thing to try and clean that up, replace it. The same with the coveralls on the right hand side of the screen. So personal protective equipment needs to be maintained and replaced frequently to make sure that it does its job. What else can we come across while loading bitumen? Well, we can be exposed to emissions, and some of the emissions that come from loading of hot bitumen can cause some irritation to the eyes and to the throat. That tends to be a very temporary phenomenon, but we can mitigate the exposure to emulsions, firstly by temperature reduction. And if we reduce the temperature by 10 degrees, we reduce the level of emissions by 50%. So that's almost like we're using that substitution strategy. We're substituting a material that's at 180 for a material at 170, and we've reduced the emissions by 50%. We also have our engineering controls, and these are examples. There are many that can be used to minimize the exposure to emissions when loading bitumen. We can install extraction systems or local exhaust ventilation to move the emissions away from the loading system and deal with them safely. We can automate loading. We can provide things that are called safe cabins, places where the driver can shield themselves from the emissions. And we can also look at remote opening and closing of man lids to stop drivers having to move to the top of a vehicle to open a man lid and allow loading or discharge. So there are a number of different strategies we can employ to reduce exposure to emissions. Hydrogen sulfide is another hazard which is associated with bitumen. You may have come across it in your school chemistry lessons. You may know, for example, that it is characterized by the smell of rotten eggs, and that's true. It does have a smell of rotten eggs, but only at low concentration. One of the problems with hydrogen sulfide, and one of the things that makes it so potentially dangerous, is the fact that at higher concentration, it deadens the sense of smell. So odor is never a reliable indicator of the presence of hydrogen sulfide, and we need to look elsewhere. Why is it such a hazard? Well, first of all, it's toxic. It has the potential to cause fatalities. It's colorless, so it can't be seen. It's flammable. It's heavier than air. And if we add to that the fact that it deadens the sense of smell, we need to think very carefully about what we're going to do to mitigate risks to hydrogen sulfide. It can also react with steel and iron in storage tanks to form things which are called pyrophoric sulfides. And these are particularly dangerous if they form inside a tank, because they can spontaneously combust in the presence of oxygen, and they can cause fires to start inside tanks. So what can we do about hydrogen sulfide? Well, the first thing we can do is carry out risk assessments, understand where hydrogen sulfide may be present. and then take some steps to mitigate the risks associated with that. Follow the safe handling guidelines from Eurobitume. We have a lot of information on H2S, hydrogen sulfide, and how it can be managed. We can look at signage. This is one of those administrative controls. We can put up signs that say H2S might be present and make them restricted areas. We can review our personal protective equipment and what's required there. And also we can use detection equipment where there is a risk of exposure to hydrogen sulfide. We can use detection systems and personal alarms to indicate that hydrogen sulfide is present. What we must never do, though, and this refers back to the previous slide, is we must never ever rely on our sense of smell to determine whether or not hydrogen sulfide is present, because it is simply not reliable. And we must never ever be tempted to enter a storage tank or a delivery tanker without a test to prove that hydrogen sulfide is not present. And that test needs to be carried out by a competent, trained person. Where can hydrogen sulfide occur? If we look at our loading operation, we tend to find it in the headspace of storage tanks above the surface of the bitumen, and we can experience some quite high concentrations there. We can also find it in the headspace of our delivery tankers. And here, if we have to open the man lid, we can take some practical steps to minimize our exposure to hydrogen sulfide by opening the man lid and allowing any hydrogen sulfide that escapes from the tank to escape away from the driver, not towards the driver. It's a simple step, but it's actually quite effective. So I've spoken so far about what we can experience at the loading of bitumen. What about at the discharge site, at the unloading site? Well, effectively, we have all of those hazards that we came across during loading of the bitumen, but then we have a series of what I would call site-specific conditions that are maybe beyond our operational control as people who are delivering the bitumen. And site-specific conditions could be anything, including vehicle movements. If we're delivering bitumen into a quarry or an asphalt plant, then there may be other site vehicles moving around, and we need to be aware of those to make sure that they do not interfere with the bitumen delivery process and they don't compromise the delivery process and make it unsafe. There may be uneven ground. We may need to take into account specific weather conditions, heavy rain, snow, ice, high temperature, even things like fog, which can impair visibility, is a site-specific risk or a site-specific condition that we need to address. And then there are some things that we need to consider which are associated with the site that we're delivering to, and that includes things like delivery pipes and vents and overflow pipes, and the condition, age, maintenance state of the tank that we're delivering to, because tank age and condition can affect the working capacity of a storage tank, and I'll come to that in a couple of minutes. So when we're unloading, what can we do again to reduce the risk? Well, one of the most important things we can do is we can work with the site to carry out a risk assessment, identify risks, and then take appropriate measures to reduce the risk. And that usually comes by developing what we call safe systems of work and procedures, guidelines and documents that illustrate how the unloading is to be carried out safely and any specific incident, situations that we need to take into consideration. We should carry out site inductions and training so that anyone who is delivering bitumen to the site knows how to get to the discharge point, what procedures are in place for the discharge, any local maintenance activities that are taking place that might affect it, and also safety critical things like the location of safety showers and escape routes in the event of an incident. And all of those should be covered in a practical site induction. And that site induction should not be a perpetual thing. It should be refreshed, revisited, and revised over time to make sure that it is absolutely relevant to the unloading process. And we can also institute exclusion zones. We can make sure that no one who is not involved in the unloading process can get within 6 meters of the delivery vehicle. And we can do that with physical barriers. We can do that with temporary barriers such as barrier tape and things like that. But it's important that we make sure that there is a 6 meter exclusion zone around the delivery vehicle during that discharge process. It's becoming increasingly common, in my experience, for reports of pressure to be sent back to us at Eurobitume, certainly within the UK. And we have to be absolutely certain. This is a site-specific concern. Poorly maintained delivery pipes, delivery lines, and poorly maintained vents can lead to pressure, and that can affect the discharge time, how long it takes to discharge bitumen into the storage tank, but it can also lead to a buildup of pressure inside a bitumen storage tank. Bitumen storage tanks are not designed to be pressure vessels. So in the worst case scenario, if pressure is allowed to build, then a tank could rupture. Why do we get carbon deposits on delivery lines and in tank vents? There are a couple of reasons, but they are effectively down to the same thing, and that is maintenance and making sure that pipes and vents are regularly inspected, because over a period of time, bitumen can deposit on the walls of those pipes and vents. It can then oxidize under the action of temperature and air, and it can build carbon deposits, and the carbon deposits reduce the diameter available to bitumen flow. It restricts flow, and it builds pressure. A similar thing can happen inside storage tanks. So it's very, very important, if we're delivering bitumen to a storage tank at a customer site, that we know exactly what the capacity of the tank is. So in this case, we have we're making delivery to a storage tank. Space here is not available for delivery. The space here is not available for delivery. So we pump our bitumen in. We leave 10% below the vent, and that gives us what we call our safe working capacity. And for the sake of this demonstration, we'll say that the safe working capacity of that storage tank is 28 tons. Over a period of time, if the storage tank is not well maintained, we can get our carbon deposits on the walls, on the roof, and at the bottom of the storage tank. And the carbon deposits start to grow and reduce the capacity of the storage tank. And that reduction can be quite significant. It can reduce the safe working capacity by, in this case, 1 ton, meaning that we've got 1 ton remaining on the delivery vehicle, or worse, if this is not known, we can get a spillage as the tank starts to overflow. So it's extremely important to know the capacity of the tank in which you're delivering into. It's equally important that any gauges or level controls are accurately calibrated and maintained, because they're safety critical equipment, and we rely on them to know exactly what capacity we have inside the storage tank, and to make sure that we don't get a spill or a build or product left on the tanker. So those are the practical steps you can take to minimize risk unloading. What should you do if you are unfortunate enough to experience a bitumen burn? And bitumen burns, I'm afraid, do happen. They are at a very, very low level, but because of a lot of the work that's been done by Eurobitume and its partner organizations, fortunately, the frequency of bitumen burns is very, very low these days. But in case of a bitumen burn, the first thing to do is to make sure that that burn is cooled for 20 minutes. 20 minutes under tepid water, not cold water, because that can create the risk of hypothermia. 20 minutes under tepid water. And then don't try to remove the bitumen, because that could lead to further damage of the skin. Only if a limb is encircled, leading to the potential formation of a tourniquet effect, we should soften the bitumen with medicinal paraffin or vegetable oil, but don't be tempted to remove it. And removal should only ever be conducted by medical professionals. So, suffered a bitumen burn, get it underwater for 20 minutes, and off to the medical professionals and let them deal with it. Practical advice is given in Eurobitume's recently updated bitumen burns card, which you can see on the side of the screen there. We have a whole host of other guidance documents which have been worked on by our HSE committee and our safe handling subcommittee, which are available in different languages and are available from our website. They cover things like boilover protection, deliveries into new and refurbished tanks, hydrogen sulfide, which we've mentioned today, safe handling, personal protective equipment, safety showers, and footwear. So all of those documents are available. We've also have our loading compatibility matrix, which you can look at. There is another reference document available to you, which I would recommend, and that is the Bitumen Safety Code, which this year was republished this year, this time as a joint publication between Eurobitume and the Energy Institute. It is a wealth of information on bitumen, and safe handling and safe storage are contained within that document, and also all of the documents that are available from Eurobitume. I want to just make a summary now, the message that I've tried to get across today. And the first thing I wanted to do was to draw your attention to the hazards that are associated with bitumen, and then how we can manage the risks. And there's some common themes that come through our risk reduction strategies, and that's instituting safe working procedures, minimizing the temperatures, incorporating engineering controls, and personal protective equipment. And that brings us right back to the message that I started with, which is that bitumen is a safe product to use when handled correctly. That brings me more or less to the end of the formal part of today's webinar. I hope that you found it interesting. I hope I've given some guidance in what to do in terms of risk reduction strategies and understanding hazards and risk. I would like to thank everybody for their attendance. If you want more information, please contact our team of experts. Contact details are there on the slide. And I think we can now move to the Q&A.